So my name is Aki. I'm one of the co-founders of Snapdrum. So my background is in machine learning. I've been doing ML, computer science for the last 13, 14 years. Sort of done a PhD, been in academia for a while, and then sort of moved in the industry. And after that, I've sort of like started my own firm that sort of focus on building sort of multi-agent systems, sort of providing consultancy services for top tier firms like and also, like, I do teach with my co-founder as well on bunch of platforms on different topics related to AI. These are like AI engineering, sort of like AI PM, sort of track, so a bunch of like courses in this space. So that's my background, and I'm quite like super passionate about AI. I've been doing this for a while, and I'm sort of like privileged to like teach some of the learnings that I'm getting from the consultancy work and sort of like teaching that. So I'm like, yeah, in a really grateful position as well. So let's dive into it. I think like the idea is like try and like give a very quick overview on like what the sort of like the term like the AI native PM, like what it looks like and what sort of like so the transition from like traditional PM and what sort of like tools out there and what can you do and different concepts around that. You probably have heard some of these things already. So like, but I want to try and put some structure around it so that it's very easy to consume. So that's the plan. All right. So the focus is like I'll broken down like this into like five sections. The initial four sections is around like sort of thinking process, like how do you sort of like approach like project development initially, like product development initially, and then you have the build phase. Like this could be prototypes, it could be like highly fully fledged applications, and how do you do that? And after that, how do you evaluate this system that you built, whether it's a voice agent system, whether it's a could be multi-agent system that you build, a RAG system, like how do you evaluate this? And how do you like make sure that like it runs safely in production? And then after you have these like things in place, like how do you push this? And like obviously, how do you have like all kinds of observability in place, like to make sure that things work fine? And then finally a bit about like the set shift about like from coming from traditional product manager, like, and how does it look like in the AI space. So we'll go into that. And obviously, I'll leave time at the end for any questions that you guys have. And feel free to like interrupt me as we go through because it's a very small class. So we have time to have a discussion as well. All right. So if you look at it like from a traditional, I know like most of you guys are like much more experienced PMs, so you probably know like what a traditional PM means. Like, so you're looking at building deterministic systems like software mostly. Could be web apps, mobile apps, like any kind of like full stack applications, things with just like services, like you're building this, right? So you're building like deterministic features, which is very easy to I wouldn't say very easy to, but there's a way to like evaluate that. Like there's a lot of literature behind it, and you know how to do it. Can be complex, but still there's a way around it. And then you have like binary sort of like pass and fail for QA. You test if something works. If it's not, like you go back and fix that. Generally, the process is like you get some requirements, you build. I wouldn't say it's done, like, but the first version is done, and you do iterations on top of that to get to the place you have to get to. And then you have like analytics in place, like things um, like Google Analytics, different types of like post hog that you have in place to make sure that you have the user interaction data, like how the product is working, things like CloudWatch. You have all of this like information to make sure how the system is behaving. So this is like the traditional sense, like on how things work. But with AI native PM, like when you build um, be a product manager in the AI space, you're thinking on different angles. Obviously, you need to have like a working like a functioning application of some sort, like, so because that you'll be drawing a lot of like fundamental from your traditional PM background, but at the same time you're bringing in new lenses to the mix, like things like thinking about the context, the cost structure, like the token cost for the product. So like really important things. And how do you sort of like have evaluation mechanisms in place? How do you evaluate like the responses, and how do you put guardrails? So it's like those are some of the things that you really need to think about. And how do you like make sure that you ship agents to production, because agents are in general non-deterministic. So because of that, how do you sort of like make sure these things works in production, and like what's the the percentage of success as well. And then how do you continuously monitor these agents? Like how do you measure things like drift? How do you measure things like if the answers are getting or the data drift or the concept drift, all sorts of areas where because AI is not deterministic, like would the system stands when things change with time. So that's what we're looking at. So like you have to like think about all of these things when you start building AI solution. So we'll like walk through this step by step what it looks like. All right. So this is like one way to look at this. Like different people will teach in different ways, but for us to think about this is like relatively, I would say, a simple sort of like view on to be a PM in the AI space, like the which you call the AI-native PM. So the first step is like obviously thinking, like figuring out like what to build and how to structure it, and that will think about context engineering, cost modeling, and then you have the build phase, like previously you would have like done prototypes, sort of like just UI based prototypes, etc. But right now you have the capability to build like a very, I would say, almost close to production, sometimes production ready applications, and then you can use that to like have like a really good conversation with your engineering team. Even like you can get like show that to users to figure out if this is the exact product that they want to use. So this is like one of the main differences that sort of like sort of democratized like PMs to actually build the products themselves and have like a really sort of powerful and like a much more closer relationship with the users as well as the engineers. So we use like things like Claude Code, Lovable, Repli to build certain applications much faster. And then you have the evaluate step where you like heard about AI evals, like how do you evaluate these non-deterministic systems, and how do you put like guardrails, and how do you think about safety, etc. So it's like super important step. And then which is the shipping part, like how do you like understand like the concepts around like building these systems, and how do you sort of observe this with time. So one of the things I sort of like emphasize a lot to any AI PM is to not just think from a PM lens, but get closer to what it looks like from an engineering point of view. Understand how models work, understand how AI systems work, because that will give you a lot more power on like on ability how to control the output. So I'll go down that route in a bit, but like just keep in mind, just because somebody's a PM, they shouldn't necessarily stop learning and understanding how AI systems work. Like get closer to as much as possible to be an engineer so that you have a lot more control over the outcome of the product. Right. So the first part, which is context engineering, right? So you heard the term prompt engineering a lot. So context engineering is an extension of that. What it means is that you'll have um, there's a lot of information that is relevant for the application. You could have like chat conversations, you could have like documents, you can have external resources, and out of that, you need to figure out what you're going to actually put in the message you send to the AI model, the large language model that you're sending it to. So that specific sort of like the area, the context window is quite precious. You shouldn't necessarily poison the space. You should only pick and choose what is relevant and what has like relatively valuable information. So figuring that part out and sort of engineering that process is called context engineering. You're defining the context and you're defining how um, the information that is out there in the application from that what sort of information that is put in the context window that is relevant for the application. So if we use tools like Claude Code, Cursor, you might have seen this very easily where you sort of like plug in like a file, you plug in like some sort of a folder and you add that to the context. So because of that, the large language model would understand, okay, this is the context. I need to answer information around this specific context. So understanding this is context engineering, and it is a lot more than prompt engineering. So prompt engineering is pretty much you sort of like control what goes in the system prompt and the user prompt, and that's pretty much it. But there's a lot more nuance around that, and like and it changes around like what sort of information comes in the application. So that's the first thing. Like when you build like AI-based solutions, like what goes into the context and like how to engineer that is super important. And then it's about like sort of figuring out these kind of like areas, right? So like what does like the context architecture looks like, and what are the guardrail requirements? So these questions you need to definitely answer in your sort of like the requirements documents, right? So and the cost model, and the model selection rationale, and the eval criteria. So I'll go to one by one, like the context architecture as we discussed. I'll probably very quickly show like example on this, like um, uh, there's like a really good um, image to show. I think this one. So what you have on the left hand side is like pretty much the traditional prompt engineering. Like you have like the prompt here, and you send that to the LLM, and you get a response. But on the right hand side, you have these like vast amount of data. You have like documents, tool calling, memory, different domain knowledge, and out of that, you like curate like what is relevant and put that in the context. So this is what context engineering means, and you'll have like some sort of a mechanism built here to make a decision at runtime to figure out like what sort of information to be put in the context window. That's what context engineering means, and having that architecture in place is a super important step. And then guardrail requirements, right? So like you're looking at like how do you sort of ensure like the input and the output, the model, the application is safe to use, and like you're sort of detecting again any kind of sort of bad words and like requests that shouldn't be executed by the application. You need to have those kind of like guardrail requirements set up. And the cost model, like this is super important. Like you might have heard so many times, like things like Claude Code, Claude models, like sort of like going through the actual AI budget of like multiple companies. Uber is one example. So having the right kind of cost model to figure out like what is reasonable and how do you sort of like manage costs, like do you like reduce the cost, select like a cheaper model, do you like sort of like work around sort of engineering like a better context. So those kind of things are like super important. And then model selection along the same lines, like how do you like select the relevant model for the right application. And then finally eval criteria, which is about like you as a PM would define like what success looks like. This is where you start normally. You define like what sort of metrics to track, and then based on that, you define the success criteria, and then based on that, you build the evals, which is like how you evaluate the responses that are coming out of your AI application. So to make sure at runtime and with time as well that it's performing as expected. So that's the main sort of like some of the like the I would say the top five sort of sections that you need to be in a requirements like AI requirements document. Um, all right, so let's talk a bit about cost modeling, right? So the first one is like the cost of goods, which is um, pretty much very similar to API call cost. So it is the unit economics, right? So at the end of the day, so you need to like figure out like what's the cost of API call, and that's what drives like the revenue, the margins, etc. And then obviously cost per query. This is like what sort of like controls how profitable your application is going to be, and that will define how do you like do the pricing and all sorts of things. So some as a PM, you need to like definitely understand this, like how the cost works across like multiple models, and at the same time, how do you make sure that is aligned with your product or the business. Uh, so in the past, this was not a requirement of a PM, but right now, this is like quite important. That's why you need to understand, okay, if you take Claude models like the Sonnet, Haiku, and then Opus models, like, and across them, how does the pricing work, and like when to use think mode, and like how to like have the system prompt properly done so that you can maintain cost, etc., etc. Like how do you like enable caching, all sorts of things. So these things are important and will get tested in like interviews if you're going for interviews on like how do you sort of like control cost around this building API for AI models. So this is something you need to like consider. And then it's about like model selection. It's like there are like bunch of model providers. there are American models, there's like Chinese models, and also like different countries are building their own custom models, but like major models are from either from US and China. And you have like Anthropic, Google, and OpenAI providing models. Like there's Grok as well. Also, there's like Kimi, Quinn, like the Chinese models, DeepSeek, which are much cheaper, but at the same time, slightly less performant than the models which are built by US research labs. But like you can sort of like figure out like when to use which, right? But some of the dimensions you need to focus on are like quality, cost, latency, and context window. For example, things like Gemini models would have like a much larger context window, which is the amount of information that you can store at like one API call. And so it's around like 1 million, like almost Gemini models. And then Claude would have like 128K. So when to use which, and like how does the latency looks like in these models, and how does the cost looks like. So Claude models are quite expensive, Gemini models are much cheaper. And if you use like a open source model, you can get things like much cheaper as well, like small language model, not the large language models, you can get them cheap as well. And quality, obviously, like the different flagship models like Opus, GPT, the 5 point, the latest models, Gemini 3.5. All of these models are like the best performing models. But you have like cheaper models like the Flash models, and then you have like older models like the Haiku, etc. Could be quite useful for high volume tasks. So depending on the actual work, you should understand when to pick which model, and you should have reasoning for that. And so one of the advice I give is like find the cheapest model that clears the quality bar. So in that way, you don't necessarily spend too much, and you're not sort of like overkilling with like model selection. And this is like a really valuable and important area an AI PM should understand. And then when it comes to sort of building, it's like prototyping. There are like bunch of options. You have things like Lovable, Replit, Bold, Base 44. All these applications would help you build like a full stack application by just prompting. So I don't know if you have seen Lovable before. To be something like this, where you write a prompt and then you get. Let me see if there are some examples. I need to log in. Let me see. So you have like bunch of sort of application like this. Let me see. So by just prompting, you can build these kind of applications, right? So it's super fast. You can get full stack application, and you can get users to use this. You can have AI, multimodal AI within this just using prompting. So it's much faster for you to go from an idea to product, like, and then you can have like this really interesting conversation with all the stakeholders. Or you can use something like Claude Code, which sort of like gives you the ability to like build things mostly locally, and have like your own sort of like application build or the product build, service build, and then that's also helps you have that conversation with the stakeholders. So this used to be engineering tasks. Now it's sort of moved on to PM side. You can build things much faster, and all the PMs who are AI native build their own prototypes from scratch without the help of engineering. So this is like a major shift happened in the last 1.5 years, I would say. And then the evaluation. So you probably need to spend a lot of time here, because LLM systems are probabilistic. They are like non-deterministic. Because of that, it's very hard to like predict how they're going to behave. How you sort of make sure the systems behave as expected is through evals. So it's pretty much around building this eval system. I'll go in detail what that means. But that system helps you to like put the right kind of QA in place so that you're quite confident that the system is working properly as expected. So one thing to remember, like it's like if you compare like traditional versus AI products. So first thing is like determinism. So software is like deterministic. You know, like when you give an input, you can expect the same output over and over again. AI products is not the same. I mean, obviously you can control some determinism, but it's not always the case. And then software, like when it comes to QA, it has like generally a binary pass or fail, when the feature works or it doesn't work. But when it comes to AI products, you generally have like a spectrum, like especially if you have like text-based answers, like it's open-ended answers. it would have a quality, like whether it's good or bad, like quite bad. So you could have like these kind of like spectrum, right? And then software, if you test it once, there's a high probability to work um, as it is for the rest of its existence. But AI solutions, you always need to check because like models get changed, the system prompts change, the users change, and all bunch of things change. So LLM systems needs like continuous like checking. Obviously, software needs as well, but LLMs, AI systems, a lot more. And then traditional software, so you'll have like a QA team generally, sort of evaluating how the system is working. And right now, PMs would control this because they understand the product really well, and they set the KPIs and the metrics on like what good looks like on the application, and that drives the eval set, which is like a known set of um, behavior for a given input, like what's the actual output that you're expecting. That's pretty much it. And then you create these evals and the evaluation criteria. And that becomes your sort of like the benchmark to start with, and you add more stuff, and the PMs would control this a lot more. Um, so, so I spoke about evals, right? So, like general process for evals is like you sort of like start with like the rubric like on what good looks like. That's where the starting point, and based on that you define, okay, for this specific input I'm expecting this type of output, and if I get that, this is like really good answer. I give like 5.5 out of 5, but certain answers I give like 1 out of 5, which is a bad example. So likewise, you have some sort of mechanism to evaluate the results, and based on that you write the test cases. So you pick the happy path, you pick the edge cases, and then you'll have this like, which is called the golden test set. You have like this set of scenarios that you can use to try and have it as a benchmark. So whenever you do a change specific to prompts, you can check this, run the system against these scenarios and see if the output has changed, right? So there are two, I would say three ways to evaluate this. There's the LLM-as-a-judge mechanisms. You have the script-based, the code-based mechanism, and then you have the human evaluators. The first one is pretty much you have like another AI model checking the results and telling you, okay, these results are good and it's the same as before, so you're good to like move ahead. And code based or script based is pretty much, so like static checks, like could be like looking for specific patterns, looking for specific words. So these are not probabilistic based checks. You're just pretty much looking at the text or like whatever the output that's come about. Could be multimodal output as well, like whatever that is, but you have like a deterministic way of like evaluating the results. And the third, like which is like the best way to do it, actually get humans to check this and sort of like check if it is good or bad, which is expensive, but that's the golden standard for checking. And then after that check, you can sort of define, okay, if the results are above a certain threshold, you can release this feature. If not, you need to revisit and like adjust like what has changed, and you can sort of control the, I would say, the decision to like release that feature or to post that until you fix it, get it to the expected accuracy level. So I think like this is like the general eval workflow. Obviously it might be a bit more complex, like depending on the use case, but on a high level you'd follow this and you continuously keep updating. This like goes in a loop. You keep updating the test cases and improving the LLM as a judge prompt, and then you sort of like go in this loop until you sort of like get to the expected threshold of accuracy. um, all right. So the other thing, like I think, like this is pretty much self-explanatory. The idea here is that PMs also need to understand safety, especially consumer-facing ones. You're looking at um, different types of blocks. Like there are things that the model should never do. Like it shouldn't necessarily tell how give instructions on how to create a bomb, something like that. So and it could be sometimes you're unsure, where you don't know how to answer a question, but you need to answer the question. So you could like sort of like fall back to a human. So this like if you have like a chat app on a banking app, this you'll see this a lot. You'll have an AI-based answering mechanism, but if the question is very specific and AI can't answer, it will like offload that to human. Sometimes you could have human in the loop, which is pretty much around for critical decisions. Like for example, let's say it's a mortgage approval process, and an algorithm would like decide if a person needs to get this or not, but it shouldn't execute the last step, because obviously an AI model cannot be held accountable if something goes wrong. So generally it was given to a human to review the answer and the reasoning, and based on that it can make the final decision. The human can make the final decision. And also, um, so what happens like when agent does something unexpected in production? So like, do you have safety in place? Like, do you have like redundancy in place? If AI doesn't work, do you have like a static mechanism to solve the problem, like a standard like software solution? Like, do you have a mechanism? So all of these things are that what like PMs need to consider when they're building application. So these are like, I would say, the top four areas you need to focus on from a safety point of view. But you also have like things around like guardrails, privacy, etc. as well. All right. So the next piece is around like shipping, like things, different things around that you need to understand a bit more. So definitely you need to understand how agents work. So this is why I mentioned like all the PMs needs to understand. Um, the multi-agent architectures and how the transform architecture works. This is going to be quite helpful for you to like think about AI solutions. But if you want to start somewhere, this is like a really good place. Try and understand like how agents work. So agents are pretty much an LLM that can sort of reason and take actions in the world. And this could be pretty much could be an agent that sort of like can do research and write articles, that can do like web search and like write really good articles and publish them on like Substack. So those like something like that could be an agent's task. So you'd have like a trigger, you'd have like a reasoning step, you have certain tools, and you have memory. Like for example, trigger is like where how that agent get executed. It could be based on an API call, it could be based on a time schedule, etc. And then you have reasoning layer, which is the large language model itself. That's sort of like based on the input that it got, it will come up with a set of steps that it needs to do to finish the task, and it will execute that based on the tools it has and do certain things. So tools are like the services that the agent has. So it could be like searching the web, it could be calling an API, doing a database read, reading some files. All of these are like tool calls that an agent has. So based on the available tools, it will like do certain steps and get to the task that needs to do, and then update the memory, and then like sort of give the results to the user. So this is what agents mean, like general agentic sort of architecture means, and understanding that is like super important. Like things like N8N, that gives especially PMs to build like AI agents like very easily. Um, so I'll show that in a bit, maybe what it looks like. Or you can sort of look at like things like OpenClaw, which is and Hermes, things like that, that helps you build these autonomous agents that can be accessed via WhatsApp, Slack, Telegram, etc. And you can do a lot more work with these kind of agents. And understanding how agents work and like the fundamentals is super critical for you to implement agents out in the wild. Um, and then another sort of concept is like MCP. You might have heard this a lot, like this, the word is thrown around a lot, and you might have used this as well. But understanding how MCP works, so which is stand for Model Context Protocol, which is pretty much a protocol that dictates how the communication can happen between AI services and external services. Like for example, if my AI solution needs to talk to an external database or external service, how that agent do that? Like for example, like if you've seen Claude chat, even Code, you'll see like these kind of like connections that have been done. Like this, I have to like read your Gmails, read your calendars, read your Notion page. All of these are done through MCP. So this pretty much controls the read as well as the write sort of features that the external service provides, and the MCP is the protocol that you normally define these kind of like services. So in that way, like the agent can easily understand what sort of things it can do and then sort of execute those. So this is like a broader topic, but the idea here is like think of it as like some sort of a, I would say, sort of a guideline on how we can define these communication channels between large language models and external services, and how to sort of like expose different features these external services has, and how to sort of like give the control to large language model is written on these like instructions. So this is what MCP means, created by Anthropic and used across like the entire sort of like the model development ecosystem, as like being like quite common right now. So understanding what MCP means and how to implement expose MCP servers is quite helpful. Like you don't have to necessarily do this, but understanding that is going to be quite helpful. Um, and then the other thing is like observability. So this is like a word that probably comes from software engineering, so understanding different metrics, different areas of your system, so that if you track them, you have a lot more control over like improving them, like things like latency, cost per query, like the amount of the cost that you incur for like a one-off question that you ask from the large language model, hallucination rate. So the hallucination means like large language models give answers, wrong answers when they are um, also not sure about the answer. And then fallback trigger rate, user override rate, like when users like wouldn't accept the answers given by the AI, which is like the user override rate. So all kinds of like KPIs, depending on your use case, you probably have like some custom KPIs, but you probably need to check this and evaluate this. So there are tools like Langfuse, Langsmith, so you can sort of integrate them to your large language model to try and like sort of like track these information. So I'll quickly show what Langfuse means. So it's like another tool which is out there. Let me see for now. So you'll have a tool like this. So you have like that can track all the interaction that your large language model has. And if you open it, you'll see like the input system message, the user message, and the response you got, all that information, the cost, the input tokens, output tokens, the temperature of the API call, latency, and all sorts of things are there. So these are like super important, like if you're like sort of optimizing for certain KPIs, and having this observability layer on your application is critical, and AI PM should be responsible for that. And maybe engineering team will help you set it up, but you are the person like will be looking at this data every day, figuring out if when things go wrong, okay, why did it go wrong? Like, was it like a tool calling issue? Was it a system prompt issue? So to ask these questions and like drive like the investigation and like fixing them. That's where the power of AI PM comes into play. So these kind of tools are quite common as well, and you'll use maybe not this one, like some version of it to help you understand the traces. Yeah, I think yeah, I think like if you want like remember like what sort of tools to use. These are not the only tools. There are so many other tools, but like for me, like I'll use Claude a lot more and to help me sort of think to figure out like what sort of like requirements to put and like how to do like context engineering. I'll use like the Claude chat to come up with that. And then for development space, I either use Lovable or Claude Code to build an application to be a fully fledged application, and then use that to drive the conversation and to do evals. I'll use like Cloud Code, Cowork, and also things like Langfuse to help me like run evals, do traces. And when it comes to shipping, actually building, I'll use things like N8N, OpenCloud, and also like MCP connections for me to like try and connect to external services. So some of the things that you can like remember, obviously there's a lot more to it, but they should cover like 75% of the like tools that you need to learn when it comes to building AI native products as a PM. So I think like if you remember like the mindset shift, you need to remember like, so when it comes to shipping features, you're actually shipping loops, like you're looking at like these like agentic runs and like also
They
non-deterministic.
do.
Sorry.
Cool. The counter also updates as expectedly. No changes have been done to the counter.
Oh,
And
sorry,
coming to the
Isabel.
download, the count was never shown properly for the anonymous users or external users. It was only for internal. This works for all the users. They can see the exact count.
Sorry,
They
Isabel.
can
I,
uncast their word, cast it. Everything is just as expected as it was before. Only the UI cleanup was done to remove the download.
okay.
I think she's on a different call.
Okay. Okay. Yeah, fair enough. Yeah. All good. Okay. So I think like so I think this is the last slide. I think like so for you to like think about the difference of like from a traditional PM to like a native PM, you're looking at like instead of shipping features, you're shipping loops. You're looking at these like non-deterministic systems can run for long periods of time. And like how do you sort of like address, build and sort of evaluate those kind of like systems. So when it comes to writing requirements, you're looking at writing the context, like how do you sort of like control the context and how do you sort of like define the PRD, the requirements document around that. And for QA, you're looking at starting with the metrics, like what good looks like, and letting those KPIs drive the eval suite and like picking the right examples and having the rubric there. And that's how we sort of like control the quality assurance side of things. And sort of like obviously you sort of like launch and measure, and you probably need to like launch and monitor, and you need to like evaluate your KPIs when, especially when they're sort of degrading, and you need to do interventions like either updating the prompts or changing the models. So all sorts of things like that sort of like works in like hand in hand with the evals. So these are some of the things that you need to like sort of like change the way you think. And it's very easy, like if you are coming from PM background, these are like very easy, just need to understand how AI sort of like non-deterministic systems work, and everything else will fall into place naturally. I appreciate the time, guys. Like, thanks a lot for sticking around and asking questions. Do connect. I'll like if you haven't sort of like connected with me on LinkedIn, let me share that as well in the chat. Feel free to connect in the chat. But yeah, so like if you guys have any questions in this space, feel free to reach out. I'm more than happy to have a chat as well. But yeah, we'll see you in the next one. All right, take care. Bye.